So we studied the lines. Lines, very important. We need the equation of a tangent line. It's a big deal for this class. We also do something called linear approximation, which uses a line to approximate function values. The second type of functions that we learned about is polynomials. You do with polynomials, you care about the leading term, you care about being able to factor it so you can get zeros and roots, you care about behavior at infinity. The third type of class of function we want to study is something called a rational function. Does anyone know what a rational function is? There's a natural progression to each of these functions, I feel like. Any thoughts? No. A rational function is a polynomial divided by a polynomial. Divided by a polynomial. So in general, it looks like this. P of x over q of x. And as a quick example, you could have something like x squared plus 1 over 3x cubed minus x plus 2. Polynomial divided by a polynomial. So we're going to learn how to graph rational functions as well. And we'll be able to graph them super precisely. That's a very standard calculus application. Okay. A root function, people sometimes call this a radical, but a root function is a function that's of the form like this, x to the n. I mean, x, this is the nth root of x. Okay. So I think I teach 3 classes, so I can never remember exactly what I tell each class, but I think I told you guys that we prefer to write these in exponential form, right? So we prefer to write in exponential form. So radical form looks like this. Exponential form looks like this. I'll show you an example in 1 second. So if we have radical x like this, the nth root of x, the exponential form is x to the 1 over n. Does that make sense to everybody? Any questions? All right. The reason why we liked writing it in exponential form is later on, we're going to learn how to take derivatives. And when we take derivatives, there's like a power law, a power rule. And if you wrote the radical in exponential form, then you could use the power rule. But without it in exponential form, you can't. Okay. So let me just tell you one more thing, because I want to. If I have something like this, if I have something that looks like this, maybe it should be in red. If I put an N here and an M here like this, do you guys know what that looks like? Hopefully that doesn't intimidate you. We can write it like this. We know that the inside part is just x to the m, like that. And then we can raise it to the nth root. So that's just 1 over n, like that. And then we can multiply those guys together. So that's like x to the m over n, like that. If you wanted to, you could even write this as x to the 1 over n to the mth power, like that. And you could write this, again, if you wanted to, as the cube, the nth root of x all to the m power. So all these things are equal to each other. And I hope that doesn't confuse you. Okay. I just remembered something. The final thing I wanted to tell you is this letter N has a special meaning. Do you guys know what that letter N is called? Because of the I?
Index.
Index. Nice. Okay. All right, great. So we've learned now about lines, polynomials, rational functions. Now we learned about root functions or radicals. Okay. So if we sort of package all of these different things together, you can get some functions that are called algebraic functions. So algebraic functions are functions that involve addition, subtraction, multiplication, division, roots, and radical powers, which are just like fractions, fractional powers of polynomials. Okay. So functions that are not algebraic are called transcendental functions. All right. So I don't know. It's kind of interesting. Like I throw all this terminology at you, and maybe you're kind of like, so what? Like, who cares? Some of this stuff is historical, and some of it is sort of like it helps you package the different things together in your brain correctly. When I see the word transcendental, I think transcend, like transcend means to like overcome, to leave the basic world behind, and you like transcend to a new level, and basically back in the day, everyone thought that polynomials were enough, oh, as long as you have polynomials, you combine them in different ways and express everything. And then they realized, you know what? That doesn't describe every function. There's other functions that we can't describe using polynomials. So then those functions sort of transcend the polynomial world and all the different combinations and ways we can transform it. So just some examples, just so that you're aware, trig functions, they're not algebraic. If you've seen something like e to the x, or something like natural log of x, or log base b of x, or b to the x, these are all examples of transcendental functions. So for us, we are going to study the trig guys. So we do study this. But these last guys over here, this is Math 5B. Our book, our class, we use